Good morning, everyone. Welcome to Think Big, making massive assemblies sing in SOLIDWORKS. Again, just thank you for popping on and welcome. Whether you're coming in from the general session or maybe this is your first session today, we're glad to have you with us. A little bit about myself. I've been with Hawkridge Systems for about 9 years now. I worked in technical support, and then I transitioned over as an application engineer. Right. And also a little fun tidbit about myself. I used to bowl, right, when we were able to. So it's been about like 6-7 months now. So I'm itching to get back. So today, again, I mentioned this in the beginning, but before we dive in, you'll notice on the right-hand side, there's going to be a Q&A and a chat window. Now, if you're full screen, you might need to exit out of that just to see those. The chat, the poll, and the Q&A, right? But then afterwards, you can full screen it if you like, if you want to just have it take up the whole screen. Also, if you have questions, the best way for us to answer them and to navigate through them, because obviously you're going to be taking a look at the chat as well, put them in the Q&A just so that we don't lose track of them, okay? So we want to make sure we get to your questions. At the same time, right, we have moderators Andy Rammer, that I'm also going to mention throughout the presentation, but Andy's one of our moderators. He's actually one that I learned from too. So he'll be able to help answer your questions right as they come along. Okay, so remember to put that in the Q&A. So in today's presentation, right, what are we looking at? So we're going to look at 3 specific areas. The first area is going to be symptoms and culprits. And we're going to look at the initial culprits, what we can kind of take care of first. From there, we'll look at some of the troubleshooting tools that SOLIDWORKS provides us. We can see what's kind of causing that performance dip, and then kind of dive deeper, and then really kind of uncover, for example, which parts are problematic, which sub-assemblies are, and then Andy's session tomorrow, if you haven't registered for it, make sure to register for it. He's going to dive even deeper. Right? So it's almost like this is building the foundation to help you find out what's causing it. And then afterwards, right, in Andy's section, he's going to show you specific case studies to help diagnose those, right? Then we have our performance enhancing modes. So we'll talk about like large design review, speed pack, right? We'll talk about that. And again, this is kind of giving us the foundation. And then really Andy's session is going to help us make our assemblies fly. And again, any questions along the way, right? Let me know. First one, right? And maybe you probably know a good portion of this, but if not, it's a good review. And because it's recorded, you'll be able to review back to this. But first one is save and load times. So especially when we're working with large components, right? Large assemblies, working locally is just going to be faster overall in terms of both opening and save times. So, when we're going over the network, we're just introducing another variable, right? Like our network speed. So if you're working with the PDM system, this is great because it will do this process for you. So when you check out the file, it's going to store a local copy, right? You're probably saying this in your head. And then when you save it and you check it back in, it sends it back to the network. Now, if you don't have PDM, you can still test this by doing a pack and go, right? So that's basically doing a file pack and go, and then you can get all those references from the assembly and be able to open up. You can open up and see if it's any bit faster, right? And that's just one of the initial things that we have people look out for. The second one would be rebuild performance. So here's the misconception that people will have, right? They'll actually kind of think about this. When you rebuild a top level assembly, you're actually not rebuilding all the features in the part, right? You're actually just reducing the misconception is that they think that when you're rebuilding the assembly, it's doing every single feature inside each individual part, right? When in actuality, it's just the top level features. So you're talking about like your mates and then your assembly features, okay? So the solution here would be just kind of initially thinking, hey, is there anything we can change about our assembly structure? It would be reducing the top level mates, right? And then utilizing sub-assemblies. And then in one of the tools that we'll have, we'll show you how to see how many you have instead of having to go through every single one and count, right? Lastly, we'll talk about dynamic view manipulation. So one of the main things that we just kind of cover from the get-go, right, is making sure you have a supported graphics card and then making sure you have an updated driver for that card, right? And the reason that's so important is because of the graphics pipeline. So I'll talk about the this one here. Under your system options, if you've seen it before, if you go to performance and then you go to enhanced graphics performance, you check that on. You're gonna have to restart SolidWorks. But once you have that on, you're gonna be able to take advantage of the graphics pipeline. So SolidWorks has made improvements to this, strides in this, starting with 2019. So you'll notice as you're kind of panning, you're zooming, you're rotating around the model, right, your assembly, it's gonna be smoother, it's gonna be more responsive, and you're gonna be able to achieve higher frame rates, right, when you have that on. And you can kind of see and compare the differences here, right? In 2021, they've also taken that up a level further. Now, another thing I want to point out is, as we're going this, just with the limited time that we have, we won't be able to go through every single hardware that's going to factor into this. But the next best thing is tomorrow, right, at 1 p.m., just make sure that you register for Alex's session, like Tim mentioned. So Tim's also going to be along there with Alex. They're going to talk about how to improve performance with optimal hardware and settings. So say you're in that part where you're kind of looking for, maybe you want to make an improvement to your system, or you're just kind of overhauling everything in general, make sure to attend Alex's session. He's awesome. So with that said, let's dive into SolidWorks, right? Let's see some of the troubleshooting tools at our disposal. And the two that we're going to look at is performance evaluation. So it's going to provide us information on how our assembly is performing. Then we're going to talk about assembly visualization. So it's a different way to kind of sort our information and display that to see some of the component properties we can kind of dive into. Before we do that, though, I want to talk a little bit about the open process. So what exactly goes into when you first go file open, you open up your assembly or an assembly drawing, what process does it go through? Right? And if we can kind of simplify this into the first 4 or 5 steps, and just going kind of top down, right? Going from our top all going all the way down. So the first thing is it's going to find and load the components into RAM. So, you maybe have like 100 or thousands of files. Like I know Andy asked about, for example, hey, how large are your large assemblies? The second one is you look to see if any parts or sub-assemblies, not you, but SolidWorks, looks to see if any parts or sub-assemblies are out of date, and then they'll update them, okay? Then they'll solve the mates and then position the components. So they'll locate them where they are. From there, if you're working with anything in context, anything that has external references or assembly features, right, it's going to update those. And that last process is that paint display. So this is where you can incorporate the tessellation information, right, those graphics triangles into the assembly. So what we're going to look at in performance evaluation, I'm going to pop into the program here, is we'll look at how long, for example, it could take to open, right? And then which files, for example, right? How do you locate those? Then we can see previous version reference information. If any of our components are still in the previous version, right, it'll let us know. Image quality, there'll be both very high and medium high image quality. So it'll be able to tell us, and it gives us an overview. So I don't have to right click on every one of those files and see, for example, is the tessellation all the way up there, right? I can tell right from the get-go. The display performance, along those same lines, I can see how many graphics triangles, and I can then pinpoint, oh, does that need that much amount of level of detail? And then we'll talk about appearances. So let's look at it. So you'll notice I did shut off my camera. Only reason being is just because you'll probably notice a little bubble. I want to make sure that everyone can see my screen. So here we have SOLIDWORKS, right? And how you're going to access your performance evaluation is going to be on the Evaluate tab. We'll go to Evaluate and we'll go up to the performance evaluation here. And then again, just kind of going top down, right? What are we looking for first? Well, if we're seeing something that's taking a while to load, right? It's going to tell us the details of the open document file, what parts or what assemblies, what files are taking the longest to load. Okay, you don't have to kind of search through your folders to look for them. Now, you'll see that on the right-hand side, it'll tell us open times, but then you can kind of scroll down and take a look at them. If you notice a little folder to the left-hand side, you can open them up and then see, for example, hey, this one's taking like the longest, and it's 2 seconds, but then, you know, as we had more and more components to this is about 2,000 components, it's going to add up. Also, you can go here to say show these files, and it's going to give us a list. So from this list, I can select, again, individual ones, but I can also do a shift select. So say, for example, you're trying to find the top 2, 3, 4 assembly or part files that are taking the longest to open. You can go ahead and open them up straight over here. And then obviously, as you open them up, you can kind of determine, for example, what's taking them so long to open, right? Andy's session will talk about that. We mentioned previous version references. So it's just telling me right now that all the files that this is referencing has been updated to the latest version. Now, SOLIDWORKS has given us the option. Before, you probably noticed that when you save an assembly file, it's also going to have you save all of the reference files, right, as the previous reference. As the current version. So one of the enhancements is being able to choose, right? You can choose whether you want this on or off. So right here, there's the forced reference documents to save the current major version. Now, if we have this one unchecked, only documents that have been modified in the current session are saved to the current version. The other ones are not, right? Obviously, if we have them checked, if we have this one checked on, and we save the assembly and the reference documents are going to be updated. In this case, I'm running 2020, right? So now we have that choice, right, and that option to choose. Let's see what else. Let's see what else we have available on our performance evaluation. We have display performance. So in this one, this is going to be like your tessellation information, your tessellation data, and your graphics triangles. So really, when you think about graphics triangles, your tessellations, your level of detail. So you'll notice here, very similar to our open. I can click on them individually. And one thing you'll probably notice is that this one's probably the highest. But then when you're looking, whenever it says total graphics triangles or total triangles, what it's saying, it's the component multiplied by the quantity. So it's all the triangles multiplied by all the instances, right? So not to say that that individual thruster part is 772,000, right? It's probably that divided by 7. Okay, so just keep that in mind. It's multiplied by all the instances. Same process here. If I wanted to kind of pop into here and choose, and then, you know, maybe it's just not one that I want to open up, but then there's several of them that I want to kind of diagnose at one time. That might not be the problem in mind. I can go ahead and open them up directly here. You can do a control or like a shift select, right? One of my favorites is the shaded image quality. Okay, so if you worked through that before, that's going to be in your document properties. I'll show you where that is. It's going to be the medium high image quality and very high. So what's the differentiator, right? What's the medium high versus very high? Medium high is going to be if you have that image quality slider between 60 to 80%. Your very high is going to be those that are going to be above the 80% range. Okay, same thing like before, where I can show these and I can open them up directly, for example, right? I go the same thing with the very high image quality, and let's show you what that slider looks like. If you just maybe forgot where that location is. So if I open up this bolt here, It's going to open the background. Just keep in mind, you do have to close the windows to be able to kind of access it. We can bring them back pretty easily. So that image quality slider is going to be in our system options and then into our document properties, right? If you go to image quality, you can also type in, your image quality up here, and it'll take you right there. You can see it's ranked all the way up there. So again, anything above that 80% range. So again, it's, as you move closer to the left, it's going to load faster, but, your circle is going to look more like a hexagon in this case, right? So the reason I mentioned this is if it's showing there and you have to right click to open it to obviously turn down the slider. But what if I just want to see at a high level overview are, a lot of my parts at the high range, and what number are they? So I'm not sure if you noticed it, but on the right-hand side, there was a tessellation number, okay? So right over here, and it both for shaded image quality and not, right over here, there's a tessellation number. The range is from 1 to 176. It's directly proportional to the position of your image quality slider. For instance, if it's right in the middle, right, it's going to be about half of 176, about 80, right? A little bit more than that. Then you can see that penetrator bolt. Remember, we had opened that. It was cranked all the way up there. It's pretty close to 176. So this will give you a high-level overview. And you can see a lot of them are nuts, screws, pins, right? Then from there, maybe we create a display state. We hide those, and then we unload them. We'll talk a little bit about that later. Other thing, appearances. So remember in that open process, it was that fifth process, wasn't it? So it's where I can, it's painting the appearances on the model. You have, for example, appearances you can apply to the part, obviously the face, individual bodies if you've done that before, right? And this is telling me there's 5 documents that contain over 100 appearances applied to faces, right? And most of the time, you're going to have more faces than bodies, right? So this is going to affect assembly performance. And then again, you can open these up and then narrow it down, right? The biggest thing kind of takeaway is how to find, for example, if you have 2,000 components, right? Which components are you trying to focus on? Which 2, 3, 4, 5 can you really focus on to help improve, and then improve your overall performance? So for example, if you have the appearances number over here, if it's over 1,000, you're going to see that impact when you load, when you update your components, and then also when it does the calculation of the graphics data. So one of the great things here is that it also gives you a suggestion. Hey, instead of doing it to the faces, maybe try just applying the appearances of the bodies, right? Do some kind of display state, maybe where you can utilize that, okay? And then switch it on when you need to. We have our rebuild performance over here. It's going to tell us how many mates are being evaluated. And then also our assembly rebuild report, okay? And then every time we rebuild, this is going to give us more information, but it's very similar to each one of those individual steps inside that open process. One of the important things to look out for, again, we're trying to locate what's causing this to open pretty slowly, perform, and every time we do a rebuild, right? It's this component rebuild. It's a great way to see which components are being modified and rebuilt every single time. So in this case, remember, ideally, when you do the rebuild, it shouldn't be going through every single feature, right, of the components. But this is probably one where you narrow down and see, oh, is there, for example, something that's causing these to, maybe I open them lightweight, right? Maybe they're opening up resolved. And then from there, I want to figure out, well, what's causing them to open up resolve? Because later on, you'll find in the data structure, they're going to, you'll see exactly why it's taking much longer, because it's loading up more information. We got our settings performance telling us, hey, are you utilizing large assembly? And then we have statistics, right? And lots of good statistics here. How many, for example, ones that are relevant for us is how many top level mates we have. And then also, if you're loading this up again, lightweight, in this case, I didn't. And sorry, I should have mentioned this before, but when you're doing performance evaluation, to get the most accurate information, you want to make sure that this is resolved, right? This is set to, your entire assembly is set to resolve. Now, If again you maybe did run this, just to check if your components are opening up lightweight or resolve, this will tell you how many resolve components and how many lightweight, right? Because then the theme that we're going to try to make sure that we kind of understand and kind of get across is we want to load our assemblies lightweight and then resolve on demand. Okay. Now, we have assembly visualization. That's the next part. But before we talk about that, I'm going to pop back to my PowerPoint. We're going to look at that open process again. Okay. Let's look at that. Cool. I'm back. So that open process loads all of our reference parts, right, in our sub-assemblies. So I mentioned briefly, but loading our assemblies lightweight just means less information is going to be loaded. What specific information, right, we'll talk about in the third section, but then also utilizing large design review, speed pack, simplify, or defeatured is also going to reduce, again, the level of information deeper, more. That updating the parts. So we talked about that option that you have, right? But at the same time, if you want to make sure that all your reference documents are that same version, obviously, you can also use Task Scheduler to automate that process. But then having them on the current version does help. In our statistics, we can see, for example, how we can reduce top-level mates and utilize sub-assemblies more efficiently. Because it's one less thing, for it to have to go through. Reduce in context features, right? And those assemblies, because if you have them more often than not, it's gonna, when you load it lightweight, it's still gonna try to get to be resolved. That's one of the criteria, or that's one of the maybe the scenarios that will cause it to be resolved, even though you select lightweight, right, when you open it up. And then lastly, the appearances, right? See how many appearances are, trying to do it bodies versus faces, right? And again, it's that tessellation information. Really, the more detail, the longer it's going to take to when you're doing your rebuild and your open process. From here, let's talk about configurations and display states. So configurations are awesome, right? Especially if you do them with parts. You can, you obviously have that same ability in assemblies. They're great with showing like multiple positions. And I'd also throw out the fact if, you want to do something like that, you can utilize make controller too, right? It's an awesome improvement. But you want to make sure that, especially when you're doing large assemblies and you're kind of seeing that dip, to use them sparingly, use configuration sparingly. And instead use display states where possible. Because in the background, SOLIDWORKS thinks of it almost like a skin. So when you're working with display states, it's like a skin, right? You're changing the color, hiding components. The configuration, it's almost like an entirely new assembly contained in that one file, okay? So some things to consider when you're utilizing display states is not only to hide them, but also you'll notice here, 2 ways to unload the hidden components. You can do it when you have the assembly open. You can right click and then unload the hidden components, or before you have it open, you can choose whether or not you want to load the hidden components, right? Because what that does is it unloads them from memory, okay? Obviously, by unloading them from memory, it makes the performance a little bit faster. But if there's cases where you need to show them again, like when you're cycling through display states, it's just a tear tick, little bit delay just because you're, has to load into memory. But if you don't have to do that in that current session, you can go ahead and unload them, right? Assembly visualization, right? Just checking on time real quick, see if there's any questions. Yep, Andy mentioned the file version upgrade. Awesome. Current version, perfect. Thanks, Andy. Next part I want to talk about is the assembly visualization, right? And certain properties to consider, right? We'll look at assembly visualization. If you haven't seen it already, we're going to talk about properties to consider. We'll talk about the open time, the graphics child, the rebuild time. And what's great is they're actually in their own mode. It's called the performance analysis, right? And also other ones you can add in that's going to allow you to kind of analyze the model is surface and solid body count. And then also say you wanted to check and see if something's converted to the current version, right? And with SolidWorks with everything, you're going to find multiple ways to do the same thing. And instead of having to go with performance evaluation, you can do it in assembly visualization too. So let's look at it. So coming in here, we're going to find assembly visualization here. Notice there was still that shortcut when we went through performance evaluation, right? Still available for us. And it's a great segue from that last section that we talked about, configuration to display states, right? Reason being is because this is awesome for creating display states. And what it does also, you'll notice that majority of it's in red. And the reason being is because on the left-hand side, I can toggle the color on and off. If I just click on it, turns it off, right, as normal. Turn it back on, it's gonna paint the entire assembly. It does not, right, interfere with like your appearances and your materials. It doesn't change them, right? But if you want to create like a different display state and kind of sort out different criteria, you can easily do that. You can go to the right, or on the right hand side, you can go over here to add display state, right? You can sort out information, because imagine trying to do this in the feature tree, right? If you sort it by the file name, for example, quantity, see what has the largest number of instances. Most likely they're going to be your washers, your screws, and we got to hold this together, right? Then we can also sort by mass, and that's kind of your default, right? And you probably noticed it in the beginning. I didn't have them here. I actually had the performance analysis on. But one of the things, it's almost like, as I was mentioning with the performance evaluation, is just making sure that those first several ones here is where we kind of narrow it down, right? Annie talked about the Pareto principle, where it's focusing on that top 20, top 10% of components that's maybe making up the majority of that 80% performance dip, for example, right? And as I mentioned, Andy's going to talk about, drilling down into those and seeing what to look out for. Also, if I want to change any of those columns, because we're not all looking for the same thing, I can change it. I can change it to volume, surface area, and in regards to your performance, one of the things I mentioned was your, say if I want to see if something is saved to the current version, right? I can say converted to current version, press OK, and I can obviously distinguish this number as well. Also, one of my favorites is this group identical. If I right click on this, it's a different color, but then also I have my converted to current version here. Let me go ahead and set this back to be like your mass, for example. Right, and we'll pop back over here. I like this a little bit better because it differentiates, not paints them all that same color, but it does, again, doesn't interfere with your appearances that you took so long to apply. It's gonna paint them individually in here. Okay, so then you can sort that out. Also, notice that there's this little slider. It's up on the top and also on the bottom. So say, for example, I can scroll down and I can take this and say, well, you know what? I don't need to take care of like the a lot of these small components. I can take this and drag it all the way up. And what that will do is it'll actually hide it, right? And also another thing I was mentioning with configuration display states, I think I forgot to mention, is when you're hiding components and unloading them, you don't have to worry about mates, because if you suppress your parts and your components, your assemblies, it's also going to suppress the mates too. Exactly, right? So I can hide them from here, and I can do it kind of top down, top and the bottom, and then again, utilize that to create display states, okay? I mentioned there was a little tool that we have available that's inside assembly visualization. Actually, before we talk about that, there is our flat and nested view. If you're familiar with this, this is going to be a different way to, again, visualize your top level. So all of your sub-assemblies are nested under, obviously it's sub-assemblies. This is giving us our top level view, right? You can obviously set it to be flat, where we see all the individual parts. grouped and ungrouped, and then performance analysis. So if I'm concerned with looking at those three, right, what were those three? Graphics triangles, open time, and rebuild time. You don't have to remember them because once you turn it on, it's available, right? Only drawback, I guess you could say, is you unfortunately can't really change these ones because it's almost like that mode, but it does give us a lot of valuable information, right? So for example, the rebuild time is going to be the rebuild time of the part in its own window. And it's not necessarily contributing to the rebuild time of the assembly, but if you're seeing something that's taking much longer than it should to rebuild, then you'll probably want to take a look at that, right? And see if that should be taking that long to rebuild. You can also see that it's probably ranking up there in terms of the open time too, right? Determine which components are taking the longest to open. Maybe you want to create like a simplified configuration of it or like a defeatured reference. And then total graphics triangles. So again, whenever you see total graphics triangles, it's all the triangles inside that component multiplied by its instances. And again, it's that level of detail. It's that graphics burden that's on the assembly. How to drill down and see exactly, okay, what has the most, and seeing if I can kind of improve upon it, right? Another cool ability you have is when you do a save as, what that does is it creates an Excel spreadsheet. So from this Excel spreadsheet, you can grab all this information, say you love spreadsheets, you can save it out, and then you can also do a comparison. And again, you can look at all of them. You can just isolate the top 5, for example. Then you make your changes. You make your changes that Andy's going to talk about, and you improve on them, and then compare them, right? Run this again and see, hey, is my graphics triangles going down? Is my open time, is it ranking lower now? And then also my rebuild time, right? You can obviously sort by file name. Maybe that's moved up and down along there. Excellent. Okay. Now, takeaways. When we're doing this, it doesn't change the material colors, right? You can always revert back to what it is. And again, it's just a mode. But I can create display states, working display states that allows me to quickly, right, navigate between every one of those to open, right? Excellent. I'm going to close this one down. And then let's pop in back to our PowerPoint. And we'll take a look at some of the additional just overall tips. And again, just making sure that we kind of take care of this now so that later on it doesn't kind of bite us, is fixing errors as they come up, right? And ideally, we'd like to model and have it set so that at the end, we kind of take care of anything that comes up. But it's easy to fix them as they come up so that they don't compound. Because sometimes you'll probably notice in a part or an assembly, as you solve one thing, it kind of cascades, right? Fixes as another thing and goes from there. Also, there's a way where you can right-click on the mates menu and you can group them by status. If they're errors, if they're suppressed, for example, if you needed to be suppressed and trying something out, and then also if it's resolved, right, and it's fixed. Also, make sure that circular reference mates aren't kind of causing you issues. So avoid daisy chaining, like, mating this to this and then mating this one to that reference, because it kind of creates that dependency, right? Doing good on time, about 10:34. Excellent. And probably should have ran these polls, but I think this is a good time as any, right? Just to run it. Obviously, you've seen these two before, but first one is, have you worked with performance evaluation before? I'm just going to launch that real quick. And you should see it pop up. Again, if you don't, just see if you can exit out of the full view window and then go and answer that there. I also need to answer it as well. So I am going to say yes. Oh, looks like so far, about 12 responses. Looks like a majority is not, right? And it's kind of a lot of collection of settings, right? To kind of go through. Oh, nope, I've jumped up. Awesome. We're about 56 to 43 so far. Majority, it looks like yes. Oh, it's kind of like tying out a little bit. I'll give it like 2 more seconds here. I wonder if it's going to even out. Right now, oh, it's about neck and neck. Wow. 53, yes, and then 52, no. Okay. And what about assembly visualization? Right? Have you used that before? Have you tried it? If you attended like a recent assembly modeling class, right, it should be yes, right? If you were following along, of course. I'm going to say yes. Like majority so far is no. Is it going to level out a little bit? Oh, wow, it's increased. We'll give it 2 more seconds. And I'm glad you guys find the poll. Sounds like it's pretty easy to find, huh? Awesome. I'll end it here. This one's pretty drastically different. This one's about 70% no and about 30% yes. Okay, awesome. Good, easy way to kind of try this out. Last section, we're going to talk about performance enhancing modes. Okay, we'll talk about large assembly mode and lightweight. We'll talk about large design review and then also reducing detail. And before we talk about this, let's talk about the data structure, right? What goes into your into our files, into like our parts, for example, right? There's 3 parts. First one is parasolid. That's going to be like your geometry. So that's your surfaces, edges, vertices, right? Information there. Then there's the tessellation. So that's going to be like your graphics triangles, your display, right? What's being displayed. And then parametrics. So features, mates, and equations. When you fully resolve something, you probably know this already, right? Is that it's loading everything, parasolid, tessellation, and parametrics. When you load something lightweight, if you probably just take a guess, right? Wonder, what is it loading up? It's loading up a subset of the model data, right? If you kind of see some of the explanations, that subset is going to be the parasolid and the tessellation information. Okay. Also, large design review. That's going to be your tessellation. That's why it opens up so quickly, right? And by the way, just good to mention again, right? And kind of working with some of my colleagues, Ryan, and then also Andy, lightweight's going to give us that no compromise option, right? And then we'll talk about different ways to open it up because you can always load it up, resolve afterwards, right? And then I also know some in the chat, I'm not sure I think it was my fault, but I opened up the polls to where I wasn't sure if I set the settings so that everyone can see the results, but just I'll mention it again, assembly visualization. 30% people have used it before, 70 have not, and then performance evaluation, pretty much neck and neck, 64 and 63. Okay, so with that said, large assembly mode in lightweight. So large assembly mode, right? It's a collection of options that you can use to obviously trigger at a certain time when you have a certain number of components, and then also certain settings, like you can have it choose to not save auto recovery info, hide your planes, axes, and sketches, right? Not display and shaded edges, right? Things that take and tax the system a little bit. The other one that I want to mention here is the disable verification on rebuild, right? You have that option there. Obviously, you have it in the system options as well. So what does it do? When you have it checked on, right? When you turn verification on rebuild on, it takes the new face and it checks it against all the other existing faces in the part. If you have a complex part, this can increase your rebuild time by quite a bit. But if you have it unchecked, it doesn't have to check it around all the faces. It just does it around the adjacent faces, therefore taking less time to rebuild, right? But it's always good practice to, say it's a final version and you're just trying to make sure everything's okay. And then you can check it on back on when you do your final rebuild for your assembly, right? Lightweight. All right, we talked about the importance of lightweight, but how do you open it up in lightweight, right? It's going to be the reason faster than your resolve mode. It's going to give you kind of the no compromise option. When you want to open up, you can go to File, Open. You can go to Performance, and say you just want to automatically load components lightweight. Say after this, I'm just going to have them all go lightweight, and don't have to worry about it. Don't have to choose. You can go ahead and set this to automatically load components lightweight, right? In our System Options Performance. Then we have that slider. So say you want to be able to choose, right? You like to decide, I want to see if I want to do large design review, resolved, or lightweight. When you do your file open, there's that slider there. You can just choose it right in the middle. And then from there, you can set, and open up your components. It's the same way where, for example, if you choose you want to load or unload those hidden components. Couple ways that we can find that. So we mentioned, hey, I want to find out, I want to load my components lightweight, but you've probably seen it to where maybe certain components are coming up resolved. Obviously, you can run a performance evaluation to where we can look at, for example, what's resolved, what's lightweight, even if, for example, we opened up lightweight mode, right? One of the ways is the advanced select. So when you right click and go to advanced select here, you can pull the drop-down menu, and then there's multiple different criteria you can look for. One of them being component status. Other one, for example, saying, hey, I want to see where it's not lightweight, which means everything else, in this case, resolved, right? It'll highlight it. You can see it highlights in the graphics area, right? It does one better to where here, if you can, you see on the video on the left-hand side, if we expand out the feature manager, now it goes levels deeper. Right? And I can see and narrow down again, investigate. Hey, well, what's causing this part to make this subassembly and the subassembly above it, right, have to resolve? Another way, if you want to look out, hey, what's a different way to do this? Is the file access log. So first criteria we need to open up the assembly, right? From here, you can look in your folder, and then you can pop into your C drive. You go into your users. I take this one from Andy, right? He showed me how to do this. It's pretty awesome. You go to app data, you're gonna go into your roaming, and then from here, you're gonna find your SOLIDWORKS folder. And then there's gonna be this file access log. This is gonna give you a list of, I'll pause it here, of all your components that are resolved, okay? Then in the next slide, I'm gonna show you what certain situations may cause it to be resolved. You can look into there and see if it checks off any one or multiple of those boxes, right? Actually, Andy will talk about this too. But then what you can do is, open this up, copy and paste it, for example, save it out, and then from there, make some changes and do it again. Compare the lists. If you see it's, one component's kind of going no longer there, then obviously you can locate it too, right? But then you can see, you kind of reduce that so that less of them are loading up lightweight. Excellent. Now, here's that knowledge base article, right? And then here's the number if you want to kind of reference it afterwards, later on. It's what would cause some of our components in an assembly not to load lightweight, and then especially when you use lightweight or large assembly mode. It could be part of a feature scope from an assembly level feature because it needs to rebuild, resolve, right? It could be part of a flexible subassembly. They could contain external references that must be resolved. They're mated to other components that fall into one of those categories, right? And then also, they've been mated since the last rebuild and saved in the main assembly, okay? So it fits any one of those criterias. Again, it's kind of, you can use that to narrow down and figure out, wonder why that's opening up resolved, especially when we choose lightweight, right? Large design review. One of the things here, I am going to show this real quick. I know we're getting close on time, so I'm going to pop into here real quick And luckily, we go our recent documents, it's going to open up pretty quickly, right, with Large Design Review. And if you haven't used it before, it's the ability to, and you open it up, again, it's taking that tessellation information, and then you can add in walkthroughs, you can do a measure, you can do section views, take snapshots, right? And what I want to focus here, and then you can also edit the assembly. So say, for example, you want to edit this and then do it in Large Design Review, you can add in your mates, right? You'll be able to create and edit like linear and circular component patterns too, okay? So they've added more and more functionality and ability, as well as hide and show components. Now, what I want to mention here is just a little tip, is if I'm trying to select one component, right, not a problem. You'll see what's happening is it selects it in the feature tree, right? But if I zoom in and say I want to selectively open some of these components, I'm going to do a window selection here. That's not too bad. I can do right to left as well. And if I try to move on the left-hand side, there was like a slight lag. If I select more components, it might be a little bit fat. It might be some time too. And why is that? It looks like it's going up and down, and it's like searching for it in the feature manager, right? So if that happens to you, and you're trying to select multiple components, doesn't happen too much in your when you're resolved, and then in your lightweight and large assembly mode, right? Consider checking off one of these options. Actually, the option. The option is going to be in your feature manager. You probably know what this is already. It's the scroll selected item into view. You check this off, you press OK. Obviously, it's not going to scroll into view, but if I do my window selection, much faster, right? I have to scroll it into view. The other one, Andy showed me this yesterday, is say, for example, you still wanted to select in your feature manager, you can right click. Actually, I think I can do it inside of my, I think I got to edit the assembly first, but there's a way where you can look to it in the component tree, right? And then what's the purpose of me doing this is that so I can do a selective open, right? I can do a selective open in lightweight. Say we didn't create a display state for it, right? We can go ahead and do a selective open in lightweight. It'll hide all the other components, and then again, allow you to work on what you need to work on. Last couple things. There are 3 ways that we can reduce the amount of detail that we have. Obviously, we turn on the graphics triangles. Another one is to do a simplify. So it creates a simplified configurations of your parts and assemblies, right? It utilizes a simplification factor here based off of the overall size and of the part of the assembly, right? And then from there, you can determine which features that you want to, say, for suppress in the part, right? If you want to go another way to do this, you can use a D feature. So D feature, you can simplify geometry as well as do like a silhouette option. So with your simplify, it removes selected components and then geometry details, right? And then the silhouette, it's going to utilize the silhouette outlines of your assembly or your part, right? To create the D featured component. In 2021, you can now save that resulting D-featured file as a configuration. And then we have our speed pack, okay? If you haven't used this before, it's gonna load us our tessellation information, potentially Parasolid, right? If you use like the mated speed pack, for instance. We have a couple of videos of that on our YouTube channel, but then you can utilize this to create a quick derived configuration. You can switch around it pretty quickly and then be able to visually display what you need to, and then change back the configuration if at any point you need to see all the other information. Also, quick mention, detailing mode. It's like your large design review for your drawings, right? Model data isn't loaded, so it opens up very quickly. You can add and edit annotations, insert sketch blocks. You just can't create drawing views, right? But then you create like add sheets, move those drawing views around, right? Edit notes. One thing to keep in mind is if you're saving your drawings, right, as you're working with them, just in kind of full blown, when you're saving them, if you see any kind of, if you're not expecting it to be a little bit slower in terms of like your save time, one thing you can do is under your performance, there's a check mark called the include detailing mode data when saving. See if you can check that off, and then as you save it, see if it saves any faster. Just keep in mind, you want to do this for any drawings that you're not going to use detailing mode for, because you need this because it's going to store that graphical data in that drawing, right? Lots of information, right? Luckily, it's recorded. Key takeaways. What can we rule out? So when we look at the our symptoms, right, those three, any initial culprits we can rule out, right? Working locally versus the network. Also taking like our graphics drivers, right? Graphics card, graphics drivers, taking like that advantage of the graphics pipeline, right? Troubleshooting tools, those two. We talked about performance evaluation. So we can locate, again, investigate, find out what's has large open times, large number of detail and appearances, right? Utilize assembly visualization to display graphically triangles that have the most graphics triangles, surface and solid body counts, rebuild times, or performance analysis, and then utilize that to create display states. Then performance enhancing modes, right? Probably one of the biggest takeaways, and I guess a theme, I guess you can consider, is opening up your assembly lightweight and then resolving on demand. Then utilizing your large design review, for example, or quick edits, and then reducing the amount of detail, creating some different configurations through simplify, defeature, or speed pack. With that being said, thank you so much for your time.